Alright, this is the additional review for the quadrilaterals and other polygons test. Some of the measures of the exterior angles of any convex octagon, any convex polygon in general, is 360. So it does not matter how many sides there are. If it's a convex polygon, the sum of the exterior angles, one at each angle, or one at each vertex, is 360. Alright, how many sides does a polygon have if each exterior angle measures 72 degrees? So the sum of the exterior angles for any convex polygon, 360. And if we divide that by the number of sides, we get the value of each exterior angle. And so to solve this, we can multiply both sides by n. So we have 360 equal to 72n. To get rid of multiplying by 72, divide by 72. And so we get 5 for the number of sides. Number 3, find the sum of the measures of the interior angles of a convex octagon. So sum equals n minus 2 times 180. Do the n minus 2 first and then multiply by 180. So 8 sides for an octagon, so n is 8. Subtract to get 6. And then multiply by 180. You get 1080 for the sum of those angles. And of course, it's in degrees. Looking at the measure of an interior angle for a regular nonagon. So each of those angles will be the same. And so the sum of the interior angles would be n minus 2 times 180, where n is 9. So 9 minus 2 times 180, that's the sum of them, and they're all the same here. So we'll divide them by 9, because there's 9 of those angles, also 9 of those sides. Multiply, get 7. And then we'll multiply on top and then divide by 9. So 7 times 180 gives us 1260, and then divide it by 9, and we get 140. So each of those interior angles is 140 degrees. The angles in a quadrilateral add up to 360. If you forget that, you can split it up into two triangles, and we'll see 2 times 180, 360 for the sum of those. So for this particular problem, we have 2x plus 2x plus 20 plus 3x minus 10 plus 2x minus 10. All of that equals 360. So combine the like terms. 2x plus 2x is 4x plus 3x is 7x plus 2x is 9x. And then 20 plus negative 10 plus negative 10 is 0. And then we'll divide both sides by 9, and so x is 40. We found the value of x. Now we're trying to find the measure of angle n. So the measure of angle n is equal to 2 times x, 2 times 40, minus 10. So that's 80 minus 10, or 70 degrees. So x is 40, and measure of angle n is 70. Forgot to mention this earlier. If you don't have a paper copy of this, just pause the problem, work it out, and then watch the solution and check it. Alright, so let's list in the values they give us. FE is 8, VY is 11, and we don't know CD. So I'll just call CDX for convenience. Now the VY is the mid-segment. It's the same distance away from each of those bases. And so the mid-segment, 11, is equal to the average of the bases, x plus, or 8 plus x divided by 2. Average of the bases. Now multiply both sides by 2 to get rid of the division by 2. We get 22 equals 8 plus x, and then subtract 8. And so x must be 14, so CD is 14. The other way to think through that is as you go from this base to this one, you add 3. Keep that same pattern going because they're the same distance apart, so add 3. And so we get 11 plus 3, 14. Mid-segment is the average of the bases. Measure of angle Q. Well, these angles for a kite are congruent. So I'll just for convenience, I'll call it X. So the angles in a kite is a quadrilateral, so they add up to 180. And so we could write X plus 48 plus 110 equals 180. Combine those like terms, we get 2x plus 158 equals 180. Subtract 158 from each side. And so we get 22 equal to 2x. Divide both sides by 2. And so x is 11. So the measure of angle Q is 11. Oh, I'm sorry. I set that equal to 180 instead of 360 for a quadrilateral. Let me fix that. 360 for a quadrilateral. 360 minus 158 is 202. Much better. Yeah, 202. And then divide that by 2 and you get 101. I was thinking that angle definitely was a lot smaller than it appeared to be. So I was thinking the diagram must be a little messed up. But yes, this appears to be obtuse greater than 90, and so we do expect our answer to be obtuse as well. Angles in a quadrilateral, also parallelogram, will add up to 360, so we could write all those equal to 360. But for a parallelogram also, the opposite angles are congruent. And so for the x's, we can write 7x minus 11 equals 5x plus 29. So we'll have that equation to solve. And then for the y's, we could write, let's see, 5y minus 9 equals 3y plus 15. So solve each of these, get your x's together, subtract 5x from each side. 2x minus 11 equals 29. Two-step equation from here, add 11. We get 40 and then divide by 2. So x is 20 and then solve for y, add, oh, well, normally I'll subtract 3y from each side. Either move is fine. 2y minus 9 equals 15, two-step equation from here, add 9, you get 24 equal to 2y, and then divide by 2. And so y is 12. So we found the value of both x and y, which is what we were told to do. Number 9, we have a parallelogram. Opposite sides are congruent. So to find y, we can say 2y minus 7 equals 7y plus 3. To find x, we can say negative 6x equal to negative 4x plus 6. Alright, so we'll add 4x to each side. And then divide by negative 2. So x is negative 3. If we plug it in, this will be 18 and this will be 18 as well. So even though x is negative, the side lengths are still positive. Alright, we'll subtract 7y from each side. Add 7. Divide by 5, and so y is 2. We can plug that back in, we'll get 17 for this and for this. Number 10, we're told that it's a rhombus. So for a rhombus, all of the side lengths are congruent, and also the diagonals are perpendicular. Let's see, they give us kz is 12 and yz is 20. Ultimately, our goal is to find py, that segment, but the diagonals bisect each other. And so if we can find ky, we can double it for py. Alright, so looking at that right triangle, we have 2 of 3 sides. And so we don't know this side, I'll call it x just for convenience. Hypotenuse squared equals sum of the squares of the legs. So 20 squared, 400. 12 squared, 144. Subtract 144 from each side, and we get 256 equal to x squared. And then to get rid of squared, we'll square root. Only a positive answer makes sense here. And so this segment ky is 16, and so 16 plus 16, or 2 times 16, gives us 32 for py. Alright, this is a rectangle. The diagonals in a rectangle are congruent, and they also bisect each other because rectangles are parallelograms. So if US is 50, then each of these is 25. And our goal is to find RZ, which is 25. Most precise classification is what we're looking for. Well, we have a pair of parallel sides, exactly one pair of parallel sides, so it is a trapezoid. If the legs are congruent, then it's also isosceles trapezoid. So the most specific answer we can come up with on this one is isosceles trapezoid. 13, we have 2 pairs of adjacent sides congruent, so we call that a kite. You may be used to seeing the diagonals drawn in there and then recognize it as a kite. And by the way, the diagonals are perpendicular and one of the diagonals is bisected. Alright, since these 2 sides are parallel, cut by transversal, we can figure this out by drawing in a diagonal. And so these would be congruent. This side would be congruent to itself. So triangle 1 and triangle 2 would be congruent. And therefore, these 2 sides would be congruent. And so eventually you'll get to where you can say, for sure, it's a parallelogram. So one pair of opposite sides, both congruent and parallel, is a shortcut, a way to determine that a quadrilateral is a parallelogram. So if you recognize that right away, you could say parallelogram, but otherwise you need to think through probably congruent triangles. Probably be the best route. All right, 15. For any parallelogram, the diagonals bisect each other, so A must be 4. Opposite sides are congruent, so B must be 7. And then this other diagonal will bisect each other. Will be bisected by the other diagonal, so C must be 3.2. So this one was just a matter of looking at it and recognizing all the values. 16, trying to make this a parallelogram. Well, opposite sides must be parallel, so they must have the same slope. So if I think about going from B to C, I go down 1 to the right, 1, 2, 3, 4. So I need to move A, or travel from A and go down 1 to the right, 4. And when you do that, we have this point D. And to see that this is forming a parallelogram, to make sure it looks right, you can connect those. So these sides are parallel, they're both vertical, and then these two we force them to have the same slope, and so they are parallel as well. 17, this is a rectangle. Write everything you know about rectangles. Well, I know you could say ABCD is a parallelogram. I'm going to say that AD, that segment, is parallel to BC, and I'm also going to say that AD is congruent to BC. We can say the same type of thing about AB is congruent to CD or DC, either way. They are also parallel. Sorry, I wrote that twice. Parallel. All of the angles are right angles. So you could say the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C, which is equal to the measure of angle D. And of course, all of those are equal to 90 degrees. Or you could state that in congruence. You could say angle A is congruent to angle B, which is congruent to angle C, which is congruent to angle D. You could say that the diagonals will be congruent. So if we drew in this diagonal AC, that must be congruent to this other diagonal, DB. And there's more stuff you can probably think of, but that's a good start. Going to be looking for at least four facts that you know about whatever quadrilateral I give you. And it won't be a general quadrilateral, it will be either parallelogram or kite or trapezoid or isosceles trapezoid or a square or rhombus. So hopefully this better prepares you for the test. Peace.